Welcome to Engineering Scale Models. I'm Jason, your host, and I do models. Today we're talking about our traffic light program again. This time power and miniaturizing the boards and stuff. My drilling pad's down, so we're going to go right to the overhead here. Now I have a wide assortment of things, and we're going to take a look at each one of these. I have some power management, an actual implementation of the program on different boards and things like that. So let me get this stuff out of the way so we can look at this stuff individually. Before we get to implementation of the board, I want to talk about power. Now, you need to figure out how you want to power your diorama, your ship, your whatever it is that you want, that you're building scale model wise, or any kind of electronic you want to know how to power it. So you can make it as simple as, a couple of these AA cells. Normally you'd want to use a triple or a 6-pack of AA cells. I can't find mine. All I have is these singles. I used to make jewel thieves flashlights, but all I could find was these singles. But normally you would need at least a triple that holds AA batteries. You could put rechargeable AA batteries. You could put regular AA batteries. Whatever you want to do. Primary batteries. And you can hook this up. You can screw it to the underside of your model and just run your wires through a switch or whatever you want to do. Have it run all the time. That's fine. If you're just running lights and things like that's a fantastic idea. You can make it real simple. Just run some batteries, run some lights and a switch, and you can just run some lights. If you are running a microcontroller or something to make the lights do something more than just be on or off, you might need a little battery pack like this. This is a very falsely claimed 1,000 milliamp hour battery. It is definitely not 1,000 milliamp hours. I will tell you that right now. This is 3.7 volts lithium rechargeable battery. This is good. We'll get into how to deal with these in management. These, I don't believe these have protection on the cells, but I will check that out in another video. And then this is a salvaged battery. This is a salvaged nickel metal hydride battery, which you can also use. You can salvage a battery from a power bank. This is a good power bank, so I won't be salvaging the battery from that. I have a video that is coming up on, well, I can't get to it right now, on a power bank for my son's Switch that the USB-C connector broke on it. So we're unable to charge it. And if I'm unable to reattach this and get it to work, I'm going to salvage the lithium cell out of it, and I'll talk about what I'll do to it then, and I'll put that in the bottom of my traffic light diorama. You can also plug in to a 5mm by 2.5mm, I believe, jack, and then you can plug into that with a thing that plugs into a USB power bank or a USB wall wart. And we'll be talking about these and what I recommend to use. This is a Apple one. We'll be comparing these to one from the dollar store, believe it or not. So, and then this is a 9-volt battery connector that has a barrel jack point on there. You don't have to have the barrel jack. Like I said, you have a 9-volt battery. You could cut the wires or just get them without the jack, and then you can wire up your circuit using a 9-volt battery, and you can run your stuff. So it depends if you want it rechargeable, and you can use a rechargeable battery. You can bury it in your unit and have a jack on the side with some lights that you can plug in something to charge it, like a battery pack or one of these adapters, and then you can charge the battery. And let me talk about that now. That's going to talk about charge circuitry and power. If you're going to be running a DC jack that has like 5 volts coming in from the wall, like a power plug that has the that plugs in, that's like 12 volts, 2 amps, 12 volts, 1 amps. You run a lot of LED lighting off of that. You can use one of those, and you could plug that into your put this in your base of your model, plug that in, but then you'll have 12 volts, and that's a little too much for certain devices to run off, especially LEDs would need a lot of resistive dropper, and that's heat and things. So you can get what is a DC to DC buck converter. This has an input and an output. We'll put this under the mini camera here, and we'll take a look at what this has on there. So we have a output, and we have an input, and then we have an inductor. It looks like we have it's probably a MOSFET. We have a trim pot to adjust the output voltage. We got a couple of smoothing capacitors. We got a protection diode there, and some tiny capacitors, an LED, it appears to be an LED, and a resistor for that LED. Let me just take a look here. Yeah, we got a resistor for the LED. Yeah, that's an LM259BS. So that, I believe, is a voltage regulator. So that is a voltage regulator. So that will get you the voltage you need, and you could have your, your 1 amp, 12 volts, 24 volts, whatever, coming in here, and it can come in here, and you can step it down to the voltage that you need to run your circuit. Now, you could actually step it down to multiple different voltages and run something on 3.3 volts, or you could have it step down to 5 volts, and then you could have 2 lines, one running your microcontroller and then one supplying higher amperage and stuff for your LEDs and your motors or whatnot, what have you, that you're building. Now this is kind of large and clunky. If you're doing a base on the diorama, this is not that bad to go in there. But if you're doing like a ship or something like that, this may be, or a tank, this may be a little much to stick in there. So you might want to stick with going with a little rechargeable battery like this. This is pretty small. This will run some LEDs for a good amount of time. Can't leave it on all the time, but if you can recharge this, that'd be fantastic. And I have 2 different models of battery protection charge circuitry here. They're both very tiny. I'm going to put them both in to the view here. Should still be focused down on that. So these are charge protection circuits. You have your power that comes in here and your battery here, and then your battery. This actually looks like it can take 2. This can support 2 batteries. So this is your charge circuitry. These are for lithium batteries. These will charge and protect your lithium battery from being discharging too low, and then you can hook up, like I said, you can put one of these wall jacks in there, and you can plug it in, and you can charge up your lithium battery from a power bank or what have you. So lithium charge circuits, if your battery doesn't, you should always try to get a battery of protection on it just in case your protection fails. But this is pretty small. You could fit this anywhere, and then you can recharge your battery, and you can run off of here to whatever your controller is, and we're getting to that next. So there's some battery protection. There is that. So that is battery protection for batteries. And now we have the different. I have this one here also. This is a charge controller for lithium packs. It has an LED display on it. You hook your battery up to it, and you charge through this port here, and it even has USB outputs if you want to run multiple things with cables like this, you know, go into DC jacks, it can get pretty extreme. These are so cheap. So these are like what's in a battery pack. So yeah, that's another option for circuitry. Now for control, this I believe is a, does it say on here? I think this is an ESP32. Nope, this is an ESP. I can't read it. This is the ESP 8566. So this is the ESP 8566. This is a microcontroller with Wi-Fi. So if you want a microcontroller with Wi-Fi, you can use these. You can program these with Arduino. There's other ways to program these. I haven't worked with these too much, but I know that you can set these up with Wi-Fi, and you know, you can turn them on and off and whatnot. And then along that lines, this is an ESP32. So this is another version of the ESP that you can use and you can program to run your unit. Here is another version that has a LCD display on it. So if you know, are interested in that, there's these type. This is nice because this one has the lithium battery plug-in, and it actually fits this lithium battery here, so you can plug it in and power it, and I believe it will charge your battery. So that's a microcontroller. Now if you want to get down to the bare bones, you could throw an Atmel Uno chip in your breadboard and go from there, but that's a little much. You can use one of these AT Tiny chips. This is nice. This plugs into a USB plug, and where this comes nice is if you have this charge controller here, you can have this set up in a base, and you can have your power to charge it, and then you can plug in your microcontrollers, you know, 2 of them, and then you can run 2 different sets of circuitry. You can run 2 different sets of lights, 2 different sets of programs, and you can actually run both of these just plugged in, one plugged into each one, and then, you know, run, and you just have to run power to this board, and you'd have it hooked up to your battery. This is a option if I scavenge the battery from that battery pack. It's supposedly 10,000 milliamp hours. I am going to use something like this and these little chips here to run the circuit the way I want to run it in a little small housing underneath the model. So this is an option. This is a very tiny chip. I believe you have looks like 4 or 5 pins. Yeah, 5 pins basically. I believe a couple are input, so you have a reference pin D0, then you have P2 is a digital or analog, P3 is digital or analog, P4 is PWM, and P5 is digital or analog. So this could run 2 shift registers, one for each set of my lights. Then I can use the other one to run a couple other things. So this is a cool option for small compactness. You know, if you want to fit it all neat in a small box. And then the Uno, this is eventually, this is programmed just like the Uno. This is the Nano, I'm sorry. This is pretty simple. You can plug this in. You can run this off a battery pack. You can run it off a USB lead that you charge from a battery pack, or, you know, and things like that. So this is the Nano. This is also in the running for the final project. I haven't decided yet. And then if you had this out, I wasn't going to talk about it. Alright, I'm not going to talk about it. But you can get circuit board kits that, you know, this is circuit board kits with pins and headers, jumpers and terminals, dual block terminals, 4-block terminals, and tons of circuit boards, different sizes. So we're gonna have the circuitry put on there, but I have a kit of circuit boards that come with a acrylic case, and they're laid out just like one of these breadboards. So if you build your circuit and it fits in, from here over of this breadboard, you can actually just take everything off, solder it to the little half breadboard, put it in the case, drill your holes for your buttons or your lights, and there you go. So you could use one of those cases and you could put your charge circuitry on it and your input, and then you just have a little black box that has everything on there, and it actually is laid out. The breadboard that comes with it is laid out just like half of one of these breadboards. So it's pretty cool. I have some plans. Hopefully I'm going to use those for my Code Crack game, but that is going to do it for this. If you want full compact, you can get these AT Tiny 85s. I don't think I put that under the... that's as close as I can get to that, I believe. Yeah. So that is the AT Tiny 85. These are pretty cool. I don't know where I got those, but that was pretty cool. Here are two different versions of a Nano. Right there's a smaller one that uses a micro USB. This one uses a mini USB. So two different types of compactness. And then I showed you the two ESPs. So that is going to do it for this, guys. This is power and controller boards. If you just want to build it out of simple logic, you can use one of these, and then you can use a 3.3 volt cell. But if you need to bump it to 5 volts, you can use the buck boost. I believe this is buck boost. If not, they make a buck boost converter to where you can boost the voltage up. I don't know what these are. Nope, these are just buck converters. These go down. But I do have boost converters. So buck boost converters, so you can do that, or you can use like one of these. If you plug into here, this will give you 5 volts out. So, but that's gonna do it for this video, guys. This is test equipment on my bench. We didn't use any of it today, but this is what I use. You can visit me at these social media links. You can also support me on Patreon.